Hello everyone. Hello. Am I audible?
Yes, sir.
Okay. So so is my screen is visible? Hello. Are you able to see my screen? Slides?
Yes, sir.
Okay. So my name is Pankaj Kapni and I am TA of this Engineering Mathematics 1 course, and I'll solve some problems related to the content of the first week. Okay. Right? We have Cauchy mean value theorem, Lagrange mean value theorem, including Rolle's theorem, and then there were some uh, problems related to limits, how to calculate the limits of functions when there is a 0 by 0 form. They are called indeterminate form, right? Let me see. I don't know what is happening. I don't know. Every time someone enters the meeting, I have to admit them. Okay, let's start with the first problem. Can you see the first problem? So in this first problem, there are two functions. So one is f, which is f of x is ex, and gx is e to power minus x on this interval m comma n. Okay, and you have to find the value of c for which the Cauchy's mean value theorem hold for these two functions. Okay, so what was the Cauchy's mean value theorem? What does it say? Okay, so Cauchy's mean value theorem. Let's recall first. We recall Cauchy's mean value theorem. I don't know. I'm not able to write. Okay, so wait for 5 minutes. I'm having some problem with the writing device. Uh, I'll just join you in 5 minutes. Okay.
You are not audible, sir.
Hi. Am I audible now?
Yes.
Yes, sir.
Oh, I thought I was audible because I was asking, am I audible or is my screen is visible? No one was replying. No one also not writing on in the chat box. So now have you seen the first question? So in the first problem, we have given two functions, f of x is e to power x and g of x is e to power minus x on this interval m comma n. And we have to find the value of c such that the Cauchy's mean value theorem hold for these functions in this particular given interval. Okay. So what is the Cauchy's mean value theorem? The Cauchy's mean value theorem says that if we have given two functions f and g which are continuous in the closed interval m comma n and they are differentiable in the open interval m comma n, then the Cauchy's mean value theorem says that the f of n minus f of m divided by g of n minus g of m is equal to f prime c and g prime c for some c in this interval. This f prime c is the first derivative of f at c and g prime c is the first derivative of g at c. Now, what is what is f of n? Can someone tell me? See,
E to
f
the
of x
power
is
m.
e to power x. So f of n is e to power n, right? And f of m is e to power m. Similarly, g of n is e to power minus n, and g of m is e to power minus m. Okay. So from this equation which you are seeing, you have to just find the value of c. Okay. You just solve this equation, you will get your value of c. So thus now we are solving this equation. Okay. So just take e to power m common from the both side, right? Because n is greater than m. So what do you get if you take e to power m common from the numerator? It is same as e to power n minus m minus 1. And in the denominator, just take e to power minus 1 common. Okay, you will get minus 1 divided minus e to power again n minus m, right? What is this equal to? This is minus e to the power m plus n, right? Can you see why it is? Let me write again. Okay, just take minus common from the numerator. You'll get this is 1 minus e to power n minus m divided by e to power minus n divided by 1 minus e to power n minus m. Now you can see that this factor can be cancelled from the numerator and denominator. So this is equal to minus of e to power m divided by e to power minus n. What is that? This is minus of e to power m plus n. Why? Because e to power minus n is same as 1 over e to power n, right? And therefore you will get e to power m times e to the power n, which is equal to e to power m plus n. Is this clear up to this point?
Yes, sir.
Okay. So so in this equation 1, in the left hand side, we have our we have evaluated the left hand side and we get this is equal to minus of e to power m plus n. Okay, now we'll evaluate the right hand side. So for that we have to find this f prime and g prime. What are they? They are first derivative of f and g. So what is the derivative of ex? What is the f prime x?
E
This
to
is
the
e to
power
power
x.
x, right? And what is g prime x? This is minus of e to the power minus x, right? Okay. So what is f prime c divided by g prime c? This is equal to e to the power c divided by minus e to the power minus c. Now can you see these two things are equal? First this and this, they both are equal. So what should we see? Okay, let's simplify this again. This is equal to, again, you use these two identities which I have told you, 1 and 2. So you will get minus of e to the power 2c, right? Okay. So this says that minus of e to the power 2c is equal to minus of e to the power m plus 1, which will imply that m plus n is equal to twice of c and c equal to m plus n by 2, right? So what is your correct answer? So your correct answer is this A. Option A is correct. Did you get this problem? Is there any doubt?
Yes, sir.
You can ask. If someone having any doubt, they can ask.
No doubt, it is clear.
Okay. Okay, let's go to the second problem. Okay, so I have since the material of the first week consists of these mean value theorems and then some indeterminate forms, and of in the last section or last video, the Taylor's theorem was there, right? So I have formed this problem set in that way. So we have discussed one problem related to mean value theorems, in particular Cauchy's mean value theorem, and now we'll evaluate some limit. Okay. In the second problem, this is our second problem where we have to evaluate the limit of some function. Okay. So what is that function? This is the function, right? You have to evaluate the limit of this function at x tends to 0. Okay. Now, what our hypothesis is given that fx is differentiable at x equal to 0 and f at 0 is 0. F takes value 0 at 0. Okay. So, our problem is calculate the limit x tends to 0 e to the power fx minus 1, right? And divided by f of x. Okay. So what do you do? Just check. You can see that we are given that f of 0 is 0. Okay. So if you put 0 to this minus 1, right? What is that? What is e to the power f of 0 minus 1? Because f of 0 is 0. So this is e to the power 0 minus 1, right? What is e to the power 0? This is 1 minus 1. So this is 0. That means the numerator and denominator, when you put 0, you'll get 0. Therefore, this limit is a 0 by 0 form. So it's a 0 by 0 indeterminate form, right? So, so what can you do for this problem? Because this is a 0 by 0 form, it's an indeterminate form. You can apply L'Hopital's rules, right? L'Hopital's rule says that this limit under the given condition is equal to limit x tends to 0, the derivative of numerator divided by derivative of denominator, right? That's why your function f is given to be differentiable at 0. So what we'll do, we just take the derivative of numerator. So what is the derivative of numerator? Anyone?
E raised to f of x into f dash of x.
Okay, why? Because
It is a composite function.
okay, so we are just applying chain rule, right? Okay.
Yes, sir.
Again, divided by f prime x. This is same as limit of x tends to 0 e to the power fx. Now, can you tell what is the limit?
1. One, sir.
Right? Why? Because the limit is e to the power f of 0, which is 1. Okay. So option B is correct in this. Okay. Now let's discuss one problem related to the Taylor's series or Taylor polynomial or Taylor's mean value theorem. So what is the idea behind Taylor's mean value theorem? Like you have already seen the video lectures. So so given some function, let's say you have given some function which is differentiable some n many times, and now you want to approximate that function with some simpler functions, right? See, a function can be quite complicated, we don't know, but we know some simpler functions like constant function, basically polynomials are like simplest function. So in the idea of Taylor's mean value theorem is you want to approximate some function which is n time differentiable to with the polynomial. So you have to find so given a function which is m time differentiable f, you have to find some polynomial such that the nth derivative at a is same as the nth derivative of that polynomial at a, right? So in particular, the polynomial which you get is called a Taylor polynomial, and it is given by, let's say, if I write as p and x, then this polynomial is given by f of 0
Plus
plus f prime. Okay,
zero
let's not write 0. We'll just write at some arbitrary point a. Let's say f of a for our convenience. F prime a x. Right. This is a polynomial. Then f double prime x by 2 x square, and like this polynomial goes on up to nth derivative at a divided by n factorial and x minus a. Okay, so there was some mistake. So I'm writing this polynomial at x equal to at around a. This is x minus a square, and x minus a power n. Okay, and this is our Taylor's polynomial. And in this problem, question 3, what they are asking. So they are saying that there is a function which takes value 1 at 0. Its first derivative takes value minus 2 at 0. Its second derivative takes value 3 at 0. And its nth derivatives are takes value 0 at 0 for every n greater than or equal to 3. Right? And all its derivatives exist and they are continuous between the interval x equal to 0 and x equal to 2. Then you have to use the Maclaurin series to find the value of f of 2. Okay, so Maclaurin series is basically the Taylor series or Taylor's polynomial when you instead of a you put 0 at around 0 you evaluate this polynomial. So for this particular problem, what is the Taylor's polynomial come out? Okay, let's write this polynomial px. Now you can see that this fn of 0, the nth derivative of this function is takes value 0 at 0 for every n greater than or equal to 3. That means we will get only first 2 or 3 terms, right? So what are those? So f of 0, again f prime 0 x, f double prime 0 x square, and after that everything is 0, right? So this is our Taylor's polynomial, and using this polynomial, you have to find the value of the function f at 2. Let's write the polynomial. F of 0 is 1, f prime 0 is minus 2, so this is minus 2x, and f double prime 0 is 3, so this is 3x square. So because we are approximating our function with the Taylor's polynomial, the value of f at 2 is approximately, or is let's say equal to the value of this polynomial at 2. What is that? 1 minus 2 into 2 plus 3 into 2 square, right? And this turns out to be 1 minus 4 plus 12. Can you see some mistakes here? Can anyone point out any mistake? See, the coefficient of x minus 2, x minus a square is f double prime divided by 2, right? Whenever you take nth derivative at a or 0, you have to divide it also by n factorial. Okay, so this is f prime double 0 divided by 2. This is the correct polynomial. So you have to divide by 2. Okay, so this is 6, right? What is the answer?
3.
3. So does anyone have any problem? So everybody everyone understand this? So our answer is 3.
Yes.
Okay. So if you have any doubt with these problems, you can ask me again. Okay. So we have discussed 3 problems. One was related to Cauchy's mean value theorem, and then in one of the problem we have calculated the limit of some one undetermined form. And in third problem, we have seen one example of Taylor's mean value theorem or Taylor's polynomial. Let's again comes to this fourth problem, which is again based on mean value theorems. So here in particular, this is based on Rayleigh's theorem. Okay, so in this particular problem, function is given in the interval -3, 0 in this closed interval. Okay, and you have to find the value of c for which this function satisfies the Rayleigh's theorem. So what Rayleigh's theorem says? Okay, let's recall Rayleigh's theorem. First, let's recall Rayleigh's theorem. It says that you have a function in the closed interval. Let's say AB is one closed interval, and we'll assume that A is less than B. Okay, and let's say it's a real valued function. So in the hypothesis of Rayleigh's theorem, we say that we assume that f is continuous in the closed interval AB. Second, f is differentiable, right? In open interval AB. And third thing is that the value of function at both endpoints are same. F of A is equal to f of B. Then what we have, then Rayleigh's theorem says that there exists some point C in the open interval A comma B such that the derivative of f at C, it becomes 0, it vanishes. Okay, so you have to we have to, in this problem, we have to find this value of C at which this function, given function, satisfy the Rayleigh's theorem. Okay, so now you can see that the function is continuous in the interval, right? Because it's the product of continuous functions. So x plus 3, e to power minus x by 2, all are continuous and differentiable functions. So this function f satisfies the first two hypotheses of Rayleigh's theorem. Now for the third hypothesis, you have to calculate the value of this function at these two endpoints. Okay, let's see. So what is our function? This is fx equal to x times x plus 3 e to power minus x by 2, right? Okay, so what is f of -3? It is 0. What is f of 0? It is 0, right? So f of -3 and f of 0 are both equal. So that means the given function satisfy the all hypotheses of Rayleigh's theorem. Therefore, there exists some c in interval of -3, 0 such that the derivative of f at c becomes 0. Now, this condition will give you a equation in terms of c, and you have to solve that equation and find the value of c. Okay. So let's differentiate the function. So what is f prime of x? What is first derivative of fx? You can apply the product rule, right? You can consider this to be one function, this to be second function. You can just write it as x square plus 3x times e to power minus x by 2. Okay. So what is the derivative of this function? Just apply the product rule. In the product rule, first we differentiate the first function. Let's say this is our first function and this is our second function, right? You can give them some name. Let's say gx and hx. Okay. So if you apply the product rule, you'll get g prime x times hx plus h prime x times gx, right? You can differentiate them individually, g and h, and you apply this formula. This is called product rule for differentiation. And now gx is just a polynomial, right? X square plus 3x. What is its derivative? Its derivative is 2x plus 3, right? And you have e to power x by 2. plus what is the derivative of the second function, this hx, right? This is the exponential function. Can again apply the chain rule, because the derivative of e to power x is same as e to power x. So in this case, is e to power x by 2. Now you can apply the chain rule so that you have to differentiate this minus x by 2, which will give you minus half. So this is minus half, and you have your gx, x square plus 3x. Is this okay? Are there any doubts? If there are, you can ask. Okay. So okay, we have to just find the value of f at c. Okay, so let's take e to power minus x by 2 common first. Okay, e to power minus x by 2 we are taking common. What do we get? This is 2x plus 3 and x square by 2, because this minus half, this get multiplied with this term, and minus 3 by 2 x. Okay, you can take minus half also common. If you take minus half common, then you'll get this e to power x by 2 x square minus x and minus 6, right? Therefore, f prime c equal to 0 implies that c square minus c minus 6 is equal to 0. Why? Because e to the power minus c by 2 is never 0. Okay, the exponential function cannot take value 0. It is always positive. So we just whatever formula you use for finding roots of quadratic polynomial, because this is a quadratic polynomial in terms of c, you have to just find the value of c. Okay, you can just factorize it also. How do we factorize it? You just write c square minus 3c plus 2c minus 6 equal to 0, right? Because if you subtract 2c from minus 3c, you get minus c. So this will imply that just take common. You'll get c minus 2, c plus 2, c minus 3. Okay, so this is equal to 0. So there are, because this is a quadratic equation, there are two solutions of this equation, right? So one is c equal to 3 and another is c equal to minus 2. You have to see which one of them lies in our interval, this minus 3 comma 0, right? Because c equal to 3 doesn't lie in this interval. We have to take that particular value of c which lies in this particular interval, minus 3 comma 0, and that is minus 2. So what is the answer? The c part is the answer of this problem. Okay. Is this problem is fine? Are there any doubts? Okay, so if there are no doubts, then we'll just move to the next problem. Okay, so again, so this is one of the problem based on indeterminate forms. So we have to find the limit of some function which have indeterminate form when you evaluate it at 0. So here the function, you have to find its limit x tends to 0. Okay, now in this particular problem, actually you have to find the value of alpha plus 3 beta, right? Because we know that the limit of this function exists, and this limit of this function at x equal to 0 is 1, right? But you can also see that if you put 0 in the numerator, then what do you get? Because sine of 0 is 0, and when you multiply by 0, this 2 minus alpha cos x, you will get 0, right? And denominator is also 0. So this is a 0 by 0 form, but its limit exists, right? That means that you can apply the L'Hopital's rule to find its limits, but limit is actually given. So to apply the L'Hopital's rule, you have to put conditions on alpha beta so that this actually becomes an indeterminate form, right? Okay, let's do it. Let's try to find this limit. X tends to 0, x2 minus alpha cos x plus twice beta sine 2x divided by x cube, right? Now, okay, you can see that this is a 0 by 0 form, right? Because the denominator becomes 0, and in the numerator also you will get 0. So this means you can apply the L'Hopital's rule, and therefore this limit will be equal to limit x tends to 0, with and the function you have to the differentiate numerator and the denominator part, right? So what is the derivative of the numerator? Again, you can apply a product rule. Okay, let me write this derivative of x2 minus alpha cos x plus 2 beta sine 2x. Okay, what is the derivative? Okay, we apply the product rule. Derivative of x is 1, so you'll get 2 minus alpha cos x, and that's x times the derivative of the second function, which is equal to, because the constant function has derivative 0, so you have to differentiate cos x, and we are assuming that alpha and beta are constants. So derivative of cos x is minus sin x, so you will just get alpha sin x. Okay, and for the second part, we have 4 beta cos 2x, right? So this is our derivative of the numerator. Okay, so this is equal to 2 minus alpha cos x plus x alpha x sin x plus 4 beta cos 2x, and in the numerator we have derivative of x cube, which is 3x square. Okay, now now just verify that is this again a 0 by 0 form? Okay, so in the denominator, if you put 0, then you will get 0. So okay, so just put 0 in the numerator. What you will get? You'll get 2 minus, because cos 0 is 1, you will get 2 minus alpha. You put 0 here, you will get a 0 because it's multiplication by 0. And again here you will get 4 beta, because cos of 0 is 1. So this will give you 4 beta. So in the numerator, you are getting 2 minus alpha plus 4 beta, and in the denominator you are getting 0, because it's 3x square. You put 0, you'll get 0. But because this has to be a 0 by 0 form, because we know this limit is equal to 1, right? This limit can be calculated, and it is equal to 1, and therefore this 2 minus alpha plus 4 beta must be 0 to make this function into a 0 by 0 form. Okay, so this is our first relation between alpha and beta. Okay, so this is one relation between alpha and beta. So if you assume that 2 minus alpha plus 4 beta equal to 0, then again this limit is in the 0 by 0 form. This is again a indeterminate form. Okay, so that means we can again apply L'Hopital's rule to find its limit. Okay, so again this limit, I'm continuing after this line. This is equal to limit x tends to 0. Okay, so again we have to find the derivative of numerator. So what is the derivative of numerator? Is again alpha sin x plus alpha sin x plus alpha x cos x, right? So this these second and third term we get after applying the product rule here. And what is the derivative of the last term? This 8 beta cos sine 2x and divide by 6x, the derivative of the denominator. Okay. Again, put 0. Again, check that if it is again in 0 by 0 form or not, so that you will again have second constraint. Okay. Now, sine 0 is 0, so first two terms they will vanish at 0. Third term will also vanish. And because in the third term alpha x times cos x, if you put 0, then it will be again 0. So this is again already in 0 by 0 form. So we can again apply L'Hopital's rule. Okay, so this limit we can again write limit x tends to 0. Okay, so that's differentiate numerator and denominator. Okay, so this alpha sin x are this is coming 2 times, so I'll just write it as twice of alpha sin x, and I'll just remove one of them, this one. Okay, so what do you get after you differentiate the numerator? You get 2 alpha cos x plus, now apply the product rule to differentiate alpha x cos x. You get alpha cos x plus alpha x sin x, right? Because the derivative of cos x is minus sin x. And again differentiate the last term, and you get 16 beta cos 2x and divide by 6. Okay, so now we know that this limit is equal to 1, and now we can evaluate the limit. So what is the limit? Just put x equal to 0. So this because cos 0 is 1, you will get 2 alpha plus alpha from the second term. From the third term you get 0. From the last term we will get, because cos 0 is again 0, it's minus 16 beta, and this is divided by 6, and this must be equal to 1, right? Because the limit is given to be equal to 1. We know that this limit is equal to 1. So this is this equation gives another constraint on alpha and beta, right? So so we already have this first equation, that alpha minus 4 beta is equal to 2. Alpha minus 4 beta is 2, and from this what do you get? 3 alpha minus 16 beta is equal to 6. So 3 alpha minus 16 beta is equal to 6. Okay, so what are the values of alpha and beta? Just multiply the first equation by 4. We'll have 4 alpha minus 16 beta is equal to 8, and second equation is the same, and just subtract these equations, right? What do you get? Alpha, and these two terms will cancel because they have different sign, because we are subtracting. So when there is a minus sign, we'll just change this to a plus, because we are subtracting one from another one. And 8 minus 6 is 2, so alpha must be equal to 2. Now because now we know that alpha is 2, what is beta? From the first equation we can easily get, right? Alpha is 2 and 4 beta is equal to 2. Implies that beta must be 0, right? So you have to find the value of alpha plus 3 beta. So what is alpha plus 3 beta now? Because alpha is 2 and beta is 0, so this must be 2. So that means that the correct answer is C. This problem is fine. So are there any doubts regarding all these problems, whichever I have discussed until now?
Sir, can you show me the sum for a minute?
Sum for?
The last sum, fifth question, answer.
Okay.
Yeah, sir. Thank you, sir.
Okay, yes. You're welcome. You can always ask any problem which you have, any doubts. I was thinking that you are talking about the first problem, because in the first problem there was this constant m comma n. Okay, okay. Let's move to the last problem. So this is the last problem of our this live session. So this is again based on the Taylor's series. Okay. So what is the problem? You have given a function which is already a polynomial, right? This is polynomial is x cube minus 4x plus 3, but you have to write it as a polynomial in terms of x minus 2, right? The function is again is actually a polynomial, but you have to expand it or write its Taylor series about 2. Basically, you have to write it in this particular form, and then you have to find these values of this value of alpha plus beta plus gamma plus delta. So basically, you have to find the value of sum of all the coefficients of this polynomial, this new polynomial, which is in terms of the powers of the x minus 2, right? So okay, so let's recall again what was the Taylor series. Okay, so in general we write fx as, if you have to write it about some point, I have already told you, it is f of a plus f prime a x minus a plus f double prime a x minus a square divided by 2, plus, like, there are lots of terms, and let's write the nth term. This is n factorial x minus a to the power n, and the series just goes on. Okay, but for this given particular function, which is itself a polynomial, the derivatives will vanish after a certain point, right? Because it's a polynomial. Okay, so for given function fx equal to, let's take fx is to be x cube minus 4x plus 3. So first we'll find all these coefficients. What are, okay, so you can see that alpha must be, because alpha is the coefficient of x minus 2 cube. Okay, let's first find all these coefficients. So f of 2, because we have to evaluate it at 2. So f of 2 is 8 minus 8 plus 3. Okay, f prime 2 is, okay, first we just calculate all the derivatives. F prime x is 3x square minus 4. F double prime x is 6x, and this third derivative is 6, and after that we'll get 0. All other derivatives will vanish. Okay, so f prime of 2 is equal to, what is f prime of 2? This find it from here. 3x square minus 4 is 3 times 2 square minus 4, which is equal to 8, right? Which is f double prime 2. From this function we'll get 12. It is f triple prime of 2, because f, the third derivative is a constant function, you get 6, right? Okay, okay, let's write our function, given function fx, as a power series or a polynomial in x minus 2. Okay, so this is equal to f2 plus f prime 2 x minus 2 plus f double prime 2 divided by 2 x minus 2 square plus the third derivative, let me write it like that, divided by 3 factorial. 3 factorial is 6, right? And x minus 2 cube. Okay. Now compare your alpha, beta, gamma, right? Or delta. So delta, this is the constant. Gamma is your coefficient of x minus 2. Beta is your coefficient of x minus 2 square. And alpha is your coefficient of x minus 2 cube. Okay. That means, what is alpha? So this is your alpha, right? So alpha is equal to f3, the third derivative at 2 divided by 6. What was the third derivative? It was 6. That means alpha is equal to 1. What is beta? This is f double prime at 2 divided by 2. So what was f double prime? It was 12. So 12 divided by 2, 6. What is gamma? F prime 2. What was that? It's 8. And delta was the constant value, constant part, which is f of 2. And f of 2 was 3. Okay, and you have to find alpha plus beta plus gamma plus delta. And what is that? What is that? This, what is the
18.
value of this term? 18. Okay. That means this option C is right. Okay. So today I have discussed all the problems which I have planned. So if you want me to discuss any of these problems again, if someone wants, then I can discuss. I'll be happy to discuss that. Or if you have any other doubts, you can ask me. So are there any doubts or not? Okay, fine. So if there are no doubts, then we can conclude our live session here.
Okay. Thank you,
Then
sir.
we'll meet you again with next week. Okay.
Thank you, sir.
Okay, you're welcome.
Yes, sir.